Hi, I wanted to post the solutions to the exponential functions review, just in case you need to check any of your answers or make sure that you're on the right track or look up a specific question. So let's go through a bunch of these. I'll go pretty quickly, but you can just pause and back it up if you need to for a certain question. So this first one is multiplying exponents. The rule for that is that you add the exponents. So we keep the base of 5 and this becomes 5 to the power 5. Notice it says I don't need to evaluate, so that's a good enough answer. This one, anything to the power 0 is always 1. With this one, we're going to multiply the exponents on the top, meaning that we add the exponents because that's the multiplying rule. So we get a power of 9. And on the bottom, we have power to a power rule, so we get an exponent of 18. And then we subtract that to get negative 4 to the power of 9 minus 18, which is negative 9. And then because negative exponent rule says to make it a fraction, it becomes 1 over negative 4 to the positive 9. That's for that one. With this one, part D, we're going to subtract the exponents first so that we do the dividing rule. So we get 7 to the power of negative 2, and it's all to the power of negative 5 still. Power to a power rule says to multiply those, and conveniently, negative 2 times negative 5 ends up becoming a positive exponent. So that just becomes 10, 7 to the 10. With this one, a to the power of negative 2 times by negative 3 is going to be a to the 6, and this will be b to the negative 15. Now, to get rid of this part, which is a negative exponent, we actually leave the a to the 6 on the numerator, and we just put the b to the 15 down to the denominator. Kind of just like back here, we took negative 4 and we flipped the whole thing and made it a positive exponent. Because a to the 6 was already positive, we can't change that. We just have to kind of knock this down so that it becomes positive. F, 1 over y to the power of negative 2. To get rid of that negative exponent, we bring the y up and make it a positive exponent. So that's that page. G, we're just going to add the exponents, so 1/3 plus 2/3. You could use your calculator for that, or you can just do fraction rules, which says to add the fractions on the numerator, so you get 3/3, and 3/3 is a whole, so that's just a to the 1. Division rule says to subtract, so we get negative 3 minus 2, which is c to the negative 5. And then we always want to get rid of those negative exponents, so this would be 1 over c to the 5. This one, the negative 2 is only on the negative 5, so we're going to leave the first e there for now. And let's simplify this power to a power rule, which becomes now 2 times negative 5. They're both negative, so it becomes 10. This is assumed to have a 1 there, making this e to the 11. With any graphing, if you want to do a table of values, all you're doing is simply taking that negative exponent and putting it into the equation. So 3 times 2 to the negative 2, subtract 4. You can do this step by step on your calculator. If you choose to do it that way, make sure you do exponents first, then multiply by 3, and then subtract 4. Or if you type it in one step on your calculator, you would just type it in exactly like that, to the power of, make sure you're putting it power of negative 2, and your first answer is negative 3.25. So when x is negative 2, y is negative 3 1/4, which would be right there. Sub in negative 1 the next time. So 3 times 2 to the power of negative 1, and then subtract 4. And you get negative 2.5. So when x is negative 1, y is negative 2.5. When x is 0, 2 to the 0 is 1. So we basically have 3 minus 4. It'll be negative 1. When x is 1, we get 2. And when x is 2, 2 squared is 4 times 3 is 12 minus 4 is 8. So when x is 1, y is 2. And when x is 2, y is 2, 4, 6. It would be up here at 8. And what you're actually going to see is a curve that looks like this. That's your exponential function. Okay, the domain and range. Domain is simply x belongs to all reals because it does go left and right forever. And the range is actually y belongs to all reals, except because this -4 is the lowest spot it can ever hit, we would actually say y is greater than, sorry, not equal to, just greater than -4. I don't think I'm going to have a question like that on the quiz, but it is just a review of what we did in the first unit of the course. Okay, a word problem. So this is exponential growth because it says it's been growing exponentially. And it's growing at a rate of 14%, which a reminder is 0.14. So we need an algebraic model that represents the population since the year 1998. So population at a certain time, you'll need the formula from the other day. It starts with the initial value. And the initial value is just 1 because this dance studio started with one single dance studio. And then remember that when it's a growth rate, you have to add 1 to that. That represents 100%. So 1.14 is our growth rate because it's 100% plus an extra 14% growing. And we want to put that to the power of time. If we want to find the number of dance studios in 2022, we need to figure out how many years has passed from 2022 back to 1998. Well, there's 22 years in the year 2000, and this is 2 years before the year 2000. So we're looking for P at 24 years because there's been 24 years from here to here. So this company has had 24 years to grow its dance studios. Type that in, 1.14 to the power of 24, and timesing it by 1 is not going to make a difference. We're looking at this company having grown to 23 dance studios in that time. And that's if that company continues to grow at the same rate for the last 24 years. This one is very similar, talking about exponential growth and decay as well. Determine a formula relating the population of Springfield to the number of years t. So let's look. Springfield started with 100 people and grew at a rate of 5%. So we want the population at a certain time. The initial value is 100. Since it's growing at 5%, we want to do 1.05. So once again, the 5% plus the whole number of 1, and we'll put that to the power of t. Shelbyville is, let's do a different color for Shelbyville, blue. They had 40 people to start, and they grew at a rate of 8%. So their equation will be a starting value of 40 and an increase of 8% to the power of time. And then we want to know which population is higher in the year 1950. Since these are both based off the year 1900, we're looking at 50 years later. So we want to find P at 50 for each case. So P at 50 for Springfield was 100 people, and I believe it was 1.05. I've lost what was above, so if I'm using the wrong numbers now, you can use the right numbers, but I'm pretty sure it was 5% and 50. So we're looking at 1146.7 people. Well, we can't have 0.7 people, so we would say 1147 people. This one, Shelbyville, was 40 people to start. And was it growing at 8%? I actually don't remember now. I think it was growing at 8%. If not, you can fix it. But this is looking at 1,876 people if I use the right numbers. And then D, I would say you don't have to worry about D because we didn't really cover that one as much. All right. That is it for the review. Continue to do the practice questions and feel free to email me if you have any questions about any of that. Okay, bye guys.